Hello. So today we are going to understand what a linear equation two variable means. Okay. How many types of solutions we can have in such scenarios and how do we solve them? Right? Okay. So there are different ways to solve them, but we'll come to it afterwards. But let's first try to understand what is the meaning of linear equation two variables. So when I say linear equation means that you can create a line based upon the equation that is given to you. Okay. When I say linear equation two variables, that means a line can be drawn based upon the two unknown values in the equation. So for example, we have x minus 2y equals to 3. I can also write it as x minus 2y minus 3 equals to 0. So both of them are the same thing, right? Because I have just taken 3 to the left hand side part in this one, right? So this is the same thing. So here, if you see in this equation, what we have is, so let's say, yeah, okay. So here what we have is, we have two unknown variables, x and y, and we want to, let's say, create a line or present it pictorially on the chart, on the graph chart. Okay, so that we can do. How we can do it is, before we come to that, let's understand what is the meaning of it. So when I say we have equation which has two variables, that means the variables values will change the value of the equation. Okay, so however x varies, the value of y will also vary, because we have this equation, if you see here, x minus 2y minus 3 equal to 0. So if I increase x, y has also needs to be increased, so that we still get the value as 0 for the equation. Okay. So that is the first thing that we want to understand here. Now, since we have only x and y, so we have two variables and only one equation. If we want to find a solution which, okay, so this is a equation based upon which you can create a line in the graph chart. Okay, so that's fine. But let's say we have one more equation. Let's say 3x minus y plus 2 equals to 0. So now we have two equations, which is 1 and 2. Okay. So now if we want to find a solution of it, so what is the meaning of it? So if you see here, I have two lines. So lines can be like this, right? So the solution of this line is this particular point, which is, for this particular point, both of these equations will have the result as 0. I mean, this point will satisfy both of these lines, both of these equations. Because if I consider, let's say, this particular point, and this line is is created based upon this particular equation. So this line will, or this point will satisfy this equation, but it will not satisfy this equation, because at this particular point this line is not passing, so it will not have the value as 0 for this for the second equation as well. But for this particular point, if I put in any of the equation, the result will be same. It will satisfy both the equations. So this is the solution that we are going to find out based upon two equations. So the number of equations that are required to find the solution is equal to the number of unknown variables. So we have two unknown variables here. Therefore, we require at least two equations to find out this unique solution that satisfies both the scenarios. Okay. So this is one thing. Let's go to next part. So this is the graphical representation. So let's say that we have x minus 2y minus 3 equals to 0. And I want to plot it graphically. So this is our graph. Now, when I say, as we discussed before in the previous slide, x and y values will vary based upon their counterparts value. So let me write it like this: x equals to 2y plus 3. So I have moved 2y and 3 to the right hand side. So it becomes x equals to 2y plus 3. So let's see how the values of x vary based upon y. So if y is 0, x is 2 into 0 plus 3. So that becomes 3 only. So x equals to 3 and y equals to 0 is 1 point. If I want to see what will be the value of y when x is, so at what value of y x will be 0? So that means minus 3. So how I am doing it? I am doing it like 0 equals to 2y plus 3. So that becomes 2y equals to minus 3 and y equals to minus 3 by 2. So at minus 1.5, which is, this is nothing but minus 1.5. So at y equals to minus 1.5, x will be 0. So this is, so these are two different points that we have got. So based like that, we can go on and we can find out multiple points for this line. But based upon 2 points, we can create this line. So when x equals to 0, y is minus 1.5, right? Somewhere here, let's say. So this is 0 comma minus 1.5. Similarly, the other point is x equals to 3 when y is 0. So x equals to 3 is somewhere on the x-axis and y is 0. So I'm not going up. I'll mark it here itself. So this is 3 comma 0. So we have found out 2 points where this line is going through, and based upon these 2 points, I can create this whole line. So it will be like this. Okay. So apologies for this, but yeah, let's consider these 2 points as the point we are discussing. So these are 2 points where we have found out this line meets x and y axis. So you can leave out this particular line. So this is how we present the line on the graph chart. Okay. Now let's go to the next slide where we are going to solve equations using this. So we have two equations and we are going to solve it graphically. Okay. So the first equation is 2x minus y minus 2 equals to 0. So that becomes 2x minus y minus 2 equals to 0. Give me a minute. So what we are going to do now is, since we have to plot this line, so I'll write it like this, that we have, I'll take y, this minus y towards the right hand side. So it becomes positive. So y equals to 2x minus 2. And the other equation that we have is minus 4x plus y plus 4 equals to 0. So solve equations graphically is the question where we have two equations, and also find the difference between the ordinates of the points where given line meets y-axis. Okay, so we'll see that. So in the same way, what I have done here, let me put it like this: y equals to, I'll take both of these minus 4x and 4 towards the right hand side. So it becomes y equals to 4x minus 4. So we have two equations now, y equals to 2x minus 2 and y equals to 4x minus 4. I am going to plot these equations on the graph, and we'll try to find the solution. A single point where both of these equations are satisfied. Okay. So let's say for each value of x, let's find out the value of y, which solves these equations. So for x equals to 0, y is, so 0 into 2, 0, minus 2 is, y is minus 2 here. And similarly, if I want to find out x equals to, let's say x equals to 1. So 2 into 1 is 2, minus 2 is 0. So we have found 2 points where these equation, where this line goes through. Okay, where this equation is satisfied. So we have 2 points and we can draw the graph based upon it. Similarly here as well, let's try to find out 2 points where this equation is satisfied. So when x equals to 0, then 0 into 4 is 0, then y is minus 4. And when x equals to 1, uh, so that becomes 4 into 1 is 4, 4 minus 4 is 0. So if you see from here itself, we can see that this particular point is going to be the solution for these two lines. But let's plot it graphically and see how these equations will look like on a graph paper. The other point was uh, we have to find the ordinates of the point where given line meets y-axis. So if you see, y-axis means this particular one, right? So the points where these lines are meeting are minus 2 and minus 4. This is available, or this is, you can check from here as well, like these 2 points. So the difference between these 2 points is 2 to 4 is minus 2 to minus 4 is 2 only. So the difference is 2 between the ordinates of the point. Okay, the ordinates is called is the y-axis points. Okay, the y coordinates. So I hope this is clear. I'll move to next one. Okay. So we are going to see the next thing that we are going to see here is the types of solution. How many types of solution can be there? So let's first see two equations, and based upon that, we'll see how many types of solutions we can have. So this is a1x plus b1y plus c1 equals to 0, and a2x plus b2y plus c2 equals to 0. So there are two equations, two variables. We should be able to solve it. Now there are three scenarios here. The first scenario is we have one unique solution for these lines, which we have seen previously as well. So first scenario is unique solution. So by looking at the lines itself, I don't need to plot them graphically. I don't need to solve them. What I can do is I can just look at the lines, do a little bit of calculation, and I can tell you whether it has a unique solution or not. How to do it? Let's see. So we have this equation 1 and this equation 2. So what I'm going to do is I'm going to calculate a1 upon a2 and b1 upon b2. Once I calculate these two, if the values of these is not same, then we are going to have a unique solution. Okay. So this is one of the scenarios that we are going to see here. The second scenario is uh, there is no solution. So no solution means these two lines do not touch each other. Okay. So they are sort of parallel lines. Okay. So here again it's a1 upon a2. So here we had not equal to b1 upon b2, but here we are saying these are equal, but they are not equal to c1 upon c2. So the lines here are parallel in this case. So that's why they will never touch each other, and therefore they will not have a solution. Okay, they will not have a common point which will satisfy both the equations. The third scenario. So we have a unique solution, we have no solution. So here A1 upon E2 and B1 upon B2 are not equal, right? In this one, they are equal, but they are not equal to C1 upon C2. What is the third scenario? The third scenario is when all of them are equal, right? So we are calculating them one by one. We are calculating these things one by one, and we are able to see there are three scenarios possible. The first one is unique solution, then no solution, and here we are saying, so a1 upon a2 upon b1 upon b2 is equals to b1 upon b2 means the lines are parallel. But if the value is equals to c1 upon c2, that means the line is coincidental. That means the line is lying one upon another. It's the same line we are talking about. So it will have multiple unique solutions. Okay? Multiple solutions, sorry, not unique, multiple solutions. So here the scenario is something like this, that you are able to find a particular point. No solution means those two lines are parallel. They will not meet each other at any point. So multiple solutions is that there is only one line, and we are just talking about the same line. So this unique solution scenario you have seen already. For the multiple solution, what I can tell you is, let's say that there is line 2x plus 3y plus 7 equals to 0. And the other one is 4x plus 6y plus 14. So I have just multiplied 2 with all of them. So that's why 2 into 2 is 4x, 2 into 3 is 6y, and 2 into 7 is 14 equals to 0. So this is in fact the same line. If I take uh, 2 common from here, it will be the same line which is we have written here. 2x plus 3y plus 7 equals to 0, right? So this is the thing. We are talking about the same line only in this scenario. in the above scenario, in the no solution one, what we are saying is we have 2x plus 3y plus 7 equals to 0. And the second line is 2x plus 3y is same, because that's what we are saying. The ratio of a1 upon a2 and b1 upon b2 is same. So here the ratio is 1, but c1 upon c2 is not 1, is not same. So it's here in this case, it's not 7 but 10 here. So these lines are parallel in this case. They will not meet each other at any point. Okay. So I think this is clear. I'll move to next slide. Okay. So the next question is that we have a pair of linear equation x plus 2y plus 5 equals to 0 and minus 3x plus 6y minus 1 equals to minus 3x equals to 6y minus 1 has how many solutions is what we have to find out. So let me just write down what are the equations that we have. X plus 2y plus 5 equals to 0. Similarly, let me write down for the second equation as well, and I'll move this one to the right hand side. So it becomes 3x plus 6y minus 1 equals to 0. Let's see what is a1 upon a2 here. So a1 upon a2 are the x coordinates. So that becomes 1 upon 3. What is b1 upon b2 here? 2 upon 6, right? These are the y coordinates. 2 upon 6 is again will be 1 upon 3 only. So a1 upon a2 is equals to b1 upon b2. With this we have understood. But what is c1 upon c2? So since they are equal, we understand there cannot be a unique solution. So this one, the A part, this is out of scope. We are not going to accept this as a solution for here. Now, let's calculate C1 upon C2. So C1 is 5 and C2 is minus 1. So it is minus 5, which is not equal to 1 upon 3. So if you remember, the scenario here is A1 upon A2 equals to B1 upon B2 is not equals to C1 upon C2. So this is a scenario when we say that there will be no solutions at all. These are parallel lines, right? So the answer will be C here. Hope you understood. Okay, coming to next scenario. Check whether the equation is consistent or not. If consistent, solve graphically. So all of these questions again have come in the board exams, and that's what we are trying to solve here, these questions. Okay. So the first equation that we have is x plus 3y minus 6 equals to 0. Let's try to put the second line also in the same scenario. It is minus 2x plus 3y, and I'll bring 12 to the left hand side only. So plus 12 becomes 0. So here, if you see a1 upon a2 is uh, okay, this a1 upon a2 is 1 upon minus 2, and b1 upon b2 is 3 upon 3, which is 1. So a1 upon a2 is not equal to b1 upon b2 in our scenario. So in this case, we will have a unique solution for these lines. Okay, so let's try to find out, let's try to plot them graphically now. Let's try to find the points where they meet x and y axis, and then we'll plot them. So when x is 0, then y becomes, so 3y minus x equals to 0, 6 goes to the right hand side, and y becomes 2. 0 comma 2 is the first point where we have found out for this equation. The second point, let's say I want to have y is 0. So that means x minus 6 equals to 0, and when minus 6 goes to the right hand side, it becomes 6. So this is what we have find out till now. So let's try to find the points for the second line as well. So when x is 0, minus 2x becomes 0, and 3y plus 12 becomes 0 as well. But here y becomes minus 4, because 3 into minus 4 is minus 12. Minus 12 plus 12 becomes 0. Okay. Now, if I want to see what happens when y becomes 0. When y becomes 0, then at minus 2x plus 12 is 0. That means 12 equals to 2x, and x becomes 6. Oh, so we have find out the common point for them already. So let's try to plot them graphically now. So the points here are 0, comma 2. So when I say 0, comma 2, it will be somewhere here, right? The other point is 6 comma 0. So 6 comma 0 will be on the x-axis because we don't have any value for the y coordinate. So well, y coordinate is 0. Similarly, here point is 0 comma minus 4. So it will be somewhere here 0 comma minus 4, and 6 comma 0 is again the same point. So if I draw the line, it will be like this, and from here it will be like this. So this is the common meeting point for them, which is 6 comma 0. This is how you'll find out the solution for this question. I hope you understood all the questions here. Thank you.